Hello and welcome to Cloud on Air, our live webinars from Google Cloud that happen every Tuesday. Today we're talking about the future of databases in the cloud, and my name is Deepti Srivastav. I am the product manager for Cloud Spanner. So let's get started. So before we talk about Spanner and why we think it's the future of databases in cloud, I think it's important to go through a little bit of sort of how we got here, right? All of us, how IT and databases and just data itself got here. So for cloud, it is still very, very early. So most of global IT spend, as you can see here from Gartner, most of the global IT spend is still on-prem, and very little of it, a very small percentage of it, is actually in the cloud so far, right? So most of cloud growth is going to happen in the next 5 to 10 years, basically, right? Welcome back. Apologies for that, and we fixed the issue on our side. So we'll just continue right where we were, and we were very early in our presentation too. So it's not such a, you haven't lost anything if you're just tuning in. All right, so we were talking about global IT spend and how much of it is really in cloud. And as you can see from this chart that we've got from Gartner here, from last year's Gartner reports, basically very little of it is still in cloud. So each of these businesses and each of these infrastructures have a database, right? You always need to have a database to store your critical data or not so critical data. So for database spend, it's extremely early in terms of cloud adoption, right? So as you can see here, first of all, most of database spend is in operational DBMSs, and very little of it is actually in the sort of non-relational open source world. Despite all the sort of marketing you hear from the non-relational side of the spectrum here, most data is actually stored in relational databases. And that's sort of obvious, right? Because with relational databases, you get transactions, you get sort of atomicity of updates, you get integrity of data, you get consistency guarantees, et cetera, which are, of course, very, very useful, as we all know, for developing applications. So, obviously, this implies that a lot of the databases out there and are relational, and most of the mission-critical data that a company has will be stored in relational databases. So before we jump into sort of the growth of relational databases, it's important to talk about what we mean by mission critical, right? So when we're talking about mission critical data, what we really mean is data that is business critical, right? So loss of that data or even a glitch in serving that data affects your reputation and has financial risk to your company. So all of this data that is required for you to run your business is what we call mission critical data, and we're saying that most of that mission critical data is stored in most cases in relational databases. So again, where are we at with the current state of databases, right? So So most companies, as we talked about earlier, right, most of the IT spend is still on-prem. What that means is that most databases are still running on-prem, and most companies are then managing their own inflexible database infrastructure on premises with, an army of people trying to maintain that infrastructure and maintain their databases and keep them alive and running. And, of course, there's a huge overhead in having those. There are those companies who have, taken the leap and adopted cloud to some extent, and what that means is they're, using infrastructure as a service from cloud providers. So they're running their own database solutions on top of these cloud-provided infrastructure. So they're still in the business of maintaining, managing, and administering, and keeping their databases alive. They may not need to run the machines themselves that host those databases, but they still have to deal with the database maintenance and management. And then there are companies who have taken a bigger leap where they're actually paying a service provider to manage and run their database solutions in the cloud, right? So this means that they don't have to worry about actually keeping the database alive. There's a service that's doing that. But that still means that they have to make sure that the databases are running the way that's expected, and they have to deal with the service provider for their database service and maybe deal with other providers for other services, right? So there is some complication there. Now, apart from where the systems and the databases are running, the other limitation is in technology itself, right? So companies are running into limitations around RDBMS scale up and scale out and sharding solutions, right? So if you run out of capacity of your database, what do, right? You have to either scale up to bigger machines, or you have to sort of go to the sharded solutions, and they come with their own headaches, which we'll get into in a little bit. And finally, companies are dealing with sort of the administration and consistency challenges of scalable solutions that are also NoSQL or non-relational, right? So for those companies who've already hit the problem with their databases and the scale of them and have adopted sort of more scalable solutions that are NoSQL or non-relational, right? They're trading off scale, consistency for scale, or the traditional relational semantics for scale. They're running into challenges of sort of having the consistency issues and the challenges of running and administrating these NoSQL solutions, whether on-prem or in the cloud, right? But the technology challenges still remain. So, what does that mean for where we are in terms of the spectrum of technology? We have this very interesting trade-off between traditional relational databases and traditional non-relational databases, right? So on the business side, right, traditional databases provide you with schema, with SQL, with consistency, and the NoSQL or non-traditional solutions, don't provide you those, but they trade those off for high availability, horizontal scalability, replication, et cetera, right? Which is the exact limitations of traditional relational databases in most cases. What that means is when you want to run high availability relational databases for your mission critical applications, you have to create these highly complex architectures to provide that availability and replication and disaster recovery solutions for your mission critical data. And as you can see, sort of, you're running multiple masters, you're running read replicas for, scaling out and offloading the read-only data access, et cetera. You're trying to sort of have memcache in there somewhere so that you can do faster reads of your data, which means you have to deal with the flushing of the cache, and you have to deal with consistency issues with having multiple masters. If you need that, you have backup replicas. So managing this system, now you've gone from one database that hosts your mission critical data to this complicated architecture that, again, requires an army to maintain. You don't actually know where the bottlenecks are in some cases, right? Because the system is so fragile. And, God forbid if one piece of it can sort of somehow fails, and then you have to figure out what the cascade effects are. And in most cases, you don't actually even know what the full picture is because it's become such a complicated, organically grown beast. So going back to first principles, right? Like, what do customers want? What do you want from your database, right? So obviously you want it to be highly available and scalable. And you want it to give you data consistency so you can access data confidently for your application, and you can serve the correct and accurate data to your customers, right? And of course, from a developer standpoint, when you're building and using these databases, you want simplified operations, right? You want standards, you want single points of contact for support. You don't want to have to talk to the database provider and the infrastructure manager and the cloud provider separately, right? Like, you want to have one person or one contact point that you can go to if you have any issues. So you don't have to deal with crises by like being the coordinator of various pieces in that crisis, right? Basically, you want your databases to run while you can build and grow your application and your business, right? And this is where Spanner comes in. So why did we build Spanner? And how did we get here, right? So if we go back in time to 2005, technical infrastructure at Google had various scalable solutions because we'd already reached the scale versus consistency problem, right? So we had scalable data storage systems, but we were lacking in transactions and relational semantics in those systems. And as we've learned, right, as we all know, those relational semantics, SQL, et cetera, are very important, and they really help you run your business well. So, Google reached that point, and so the need of the hour was horizontally scaling databases with ACID transactions and global consistency. And of course, we are Google, so we want no downtime, right? We want high availability. We want you to be able to access Google from anywhere at all times. So we came up with Spanner. We developed Spanner with a lot of research and a lot of understanding of how to build distributed, scalable, highly available systems. And what we have here is basically the paper that we published in 2012 that talks about the technology that we built at the time. So Spanner was launched externally as Cloud Spanner, which is a publicly available product on Google Cloud Platform. And it's about exactly a year ago that it was launched publicly on GCP. So we're celebrating our first anniversary as a cloud database. So Cloud Spanner is basically an enterprise-grade, globally distributed and strongly consistent database service built specifically for the cloud to combine the benefits of relational database structure with non-relational horizontal scale. So what does that mean? Right, we're basically saying you don't have to trade off or make compromises between relational semantics and horizontal scale, which is what traditionally companies and IT folks have had to do, right? Database users have had to do. They've had to basically trade off and give up on relational semantics and build that in the application to get horizontal scale to manage their data growth over the course of the data exploding for their business, right? So Spanner allows you to not have to make that compromise. It's our no compromise relational database service, right? And you get all of this packaged up in a managed service so you can focus on your database and not have to worry about running, so you can focus on the application using that database and not have to worry about running the database itself. So we provide schemas, ACID transactions, SQL, and the relational scale with up to 5 nines of availability and an availability SLA, so we guarantee that. We're in a fully managed, easily scalable service. So if we hark back to our chart of what are the pros and cons of relational versus traditional non-relational services or databases, right? Basically, you don't have to make those trade-offs, right? We have schemas, we have SQL, we have consistency like traditional relational databases, and we have availability, scale, and replication. And by the way, a bunch of it is out of the box that you can get with non-relational traditional sort of NoSQL systems. So again, right, you don't have to make compromises between technical needs and business needs in order to really run your applications and your business critical data. Now there are differences, right, in the technology of Spanner and traditional relational databases and how they've worked, so far. And of course, there is innovation here that allows us to do this relational with scale, and I can touch upon a little bit of that. But the important thing to note here is, like traditional databases, you get tables, you get DDL, you get the same sort of schemas that you're used to. So you do create table, you have primary keys, etc. Right? And in this picture, you can see that we've created two different tables, which have relationships that you can see, and you use simple DDL statements in order to create this table. And you'll use sort of this sort of schema change DDL statements as well to alter table or drop column, etc. as well. So again, these are the familiar constructs that you're used to so far with traditional relational that you get with Spanner as well, with some added benefits, right? So in this case, you see these two tables, and if we were to see how this logical structure is laid out, Spanner has a concept of interleaving. It's one of the many technical differences, but it's interesting to point out as it kind of showcases how we've been built for scale with the relational transactional semantics. So in the previous case, we had two different tables, and they're logically different, right? There's the albums table and the singers table. But if you interleave the albums table and the singers table, what that means is that the data is logically co-located, right? So you essentially can think of it as a pre-join. So when you're doing large data set reads or scans, you don't have to actually do the join at a runtime, right? You can predetermine that these data sets are going to be sort of queried together, and you can logically tell the system to store them together so that they can be retrieved much faster. Now, for a few megs or a few gigs of data, right, like joining may not be a latency causing issue, but when you have hundreds of gigabytes or hundreds of terabytes of data and you need to do all albums and for all singers sort of a query, that's a lot of data to be joined and processed at runtime, at query time. So instead of having to do a join at that time, you can specify to the system that you need to pre-join this data set because your most common queries are actually going to scan the singers along with their albums, right? So in this case, the system can very quickly basically read the data and return the query results without having to do the computationally intensive join, hence reducing read time, right, or query serving time. Again, you can use interleaving for indexes as well. So we have secondary indexes, we are a relational database, and from that standpoint, you can of course have separate logical indexes which can be standard tables in other traditional databases, right? And in our case, they are standard tables as well, but you can interleave them, right? So again, if you're going to have to back join indexes with the base table because of your most common queries requiring that pattern, then you can interleave the indexes within the base table, and again, that can lead to much faster selects and queries of your data. So this is just one of the ways in which Spanner is different, but it sort of shows you under the covers, like the technological differences we have, which allows us to provide scale with relational semantics. So, as Nick says in this quote from Gartner, so when we talked about, when we launched Spanner and we talked about it with various analysts, and of course we have customers that are using it. It's interesting because it's not just another take on a traditional database, right? It's really a new way of thinking, a new need that's being met by the technologies at Spanner. But Spanner is not just software, right? It's the combination of a lot of very clever software, which there is a lot of, along with hardware that we've built specifically for scale and to provide the kinds of things that we need for a large, highly available, scalable system, such as atomic clocks that we have in-house. Like TrueTime is a technology we use for global synchronization and external consistency, right? Which is stronger than linearizability. So we use TrueTime, which is based on atomic clocks and GPS, to do this coordination, and that powers sort of Cloud Spanner as well, and allows it to have that global external consistency, which allows us to then have globally consistent and strong, strong relational semantics database in Cloud Spanner. And this is, of course, built on top of our Google network, which we've talked about quite a bunch, and there's a lot of white papers that we've actually put online as well that one can read if interested. But basically, it's a combination of our Google networking, which is highly redundant and optimized on all levels, right, from the network fabric all the way to the switches, to the to the hubs, etc. And atomic clocks and GPS with TrueTime, as well as clever software in Cloud Spanner itself. So, we, for example, have wrote our own implementation of Paxos. We don't use the open source Paxos implementation. We optimize the Paxos algorithm in our implementation for our specific use case, which allows us to, again, do low latency transactions and to do strong reads across continents and across oceanic links. And all of this kind of combines to give you Cloud Spanner. So there's a bunch of customers that are using Spanner and they're excited about it. And, I am personally excited to talk about a few of them that I've been sort of seeing them win, and it's really exciting for us to see how the world has adopted and started to use Spanner, right? So it's not just about trading off CapEx for OpEx, right? Which is what a managed database service gives you. That's kind of the promise of cloud. But with cloud, customers are trying to do inherently new and exciting things that they couldn't do before because they were limited by technology. And in this case, Optiva, which is a telecom communications billing and charging system, so as mission critical as they get, it has basically adopted Spanner as its next generation database system for its next generation sort of software for billing and charging, right? And when they looked at Spanner, they saw improved performance and reliability from their existing traditional architectures, and they actually saw 10 times more throughput, so 10 times more transactions per second at a dramatically reduced cost. So Optiva is actually presenting this week at Mobile World Congress in Barcelona, and I'm here with you and I'm not there, but it's really exciting because they're really excited about the technology, right? They're really excited about the possibilities it opens up for them and for their customers, right? And that's really the reason to have sort of Cloud Spanner as a managed database service, right? They don't have to worry about the system itself. And also, because of its combination of relational semantics and horizontal scale, they can do things with this technology that they couldn't do with their existing on-prem solutions. So another interesting example, one of my favorites, actually Marketo and the one following, is again, Marketo is a marketing platform that provides marketing applications for companies all over the world, right? And for them, in their own words, right, having order sequence in their application logic is very important. And as they were looking to go to cloud, and looking, obviously, the first step is, which cloud provider do I use? And the second question for most of us is, well, what database services do each of these cloud providers have, right? And how do I use them, right? Is it easier for me to use these services, or is it going to make my life more difficult? And with Cloud Spanner, basically, again, they could use the system to have the kind of order and sequence guarantees in the app logic, so they didn't have to write brittle application logic to have that sequencing, right? With NoSQL and with sort of systems that are scalable but lacking in transactional consistency or strong consistency, all of that has to be built into the app, right? Which means your application becomes a lot more complicated, and your team is basically stressing in keeping that system alive and running instead of building cool things to serve your customers. And that obviously is a productivity hit, but also a growth hit for you, right? It affects your business bottom line. And in this case, when you don't have to worry about that anymore, you can choose Spanner. You don't have to re-platform or think of re-platforming ever. You just grow as your global business grows. I mean, that's a powerful statement, right? And another one of our favorite customers, Evernote. I think a lot of people know Evernote. Again, they had a multiple hundred sharded MySQL system. They want their users' notes to be obviously available no matter where they are. They, with Cloud Spanner, can go to a system that reduces this complexity, gives them scale, and once they have migrated, they don't actually have to think about re-platforming ever again, right? So it reduces, in fact, eliminates all of that stress of sort of managing the complicated multi-shard MySQL system that keeps their operations team sort of awake at night. From that to sort of building more functionality and having ease of use of their application and infrastructure. So, we talked about sort of the positive things in Cloud Spanner, or how it's different from traditional relational and non-relational databases. But it's important to note that Google Cloud Platform's database portfolio is vast, right? And Spanner is one piece of it, right? We actually have Memcache all the way on the left to our sort of data warehouse in the cloud with BigQuery, right? So the way I think about Cloud Spanner and BigQuery is, if you're used to sort of traditional relational databases, and data warehouses, right? Cloud Spanner and BigQuery are sort of the cloud equivalents of those, right? But it's deliberately placed next to, Cloud Spanner is deliberately placed next to non-relational systems in this chart because, it allows you to have non-relational scale, right, along with the relational semantics that it offers. So, the whole portfolio basically allows you to have a bunch of tools that you can choose from to build the kinds of systems you need, right, for your application, right? We're not trying to tie you down to one and only one solution, but we're not giving you sort of hundreds to choose from, right? We think there are different use cases that require very specific tailored solutions for storage, and with this portfolio, we basically offer you a solution for each of those specific use cases. What that also means is, again, you have the toolkit to choose the right system, but you're not left on your own to figure out sort of which system you need to use among hundreds, right, or dozens, right? There's, as I said, a solution for each specific use case, and we help you choose the right system for the use case. So as this chart sort of shows, there's basically a flow chart that you can use to pick the system you want for the use case you have. And this is, again, up on our docs in cloud.google.com, so you can look it up there as well, along with a lot more information. So hopefully that kind of gave you an overview of why we think sort of Cloud Spanner is the future of database systems. And we'll take a short break of less than a minute and come back for a live Q&A section as well, so stay tuned. Welcome back to Cloud on Air. Let's get straight into our audience questions for the day from this webinar. So question 1, are you expecting all relational databases to migrate to cloud immediately? Absolutely not, right? Like, there are many reasons why sort of most of the cloud spend is still, most of the IT spend is still in on-prem and not in the cloud, right? As I had mentioned earlier in my talk, sort of we know that these are early days for cloud, but what we want to make sure is that customers understand that they don't need to shy away from adopting cloud because they think they can't get the performance or the semantics that they're expecting from their applications in the cloud, right? And if you're needing horizontal scale and relational semantics, for example, you don't have to sort of worry about not being able to do that in the cloud because, for example, we have Cloud Spanner on Google Cloud that will allow you to have that without compromises. So we expect, most of the cloud migration to have in the next 5-ish years, 3 to 5 years, and beyond, right? There are many reasons for not being in the cloud right now. As I said, you've already made commitments, you've already bought the machines, you've already got data center space, you've already got colo space for your data and infrastructure. So it'll take time, but I know that a lot of companies are looking at migrating to the cloud, and it's important that they see the full picture and all the options available to them so that they don't have to shy away from it for, let's say, performance or manageability or any of those reasons. So moving on, why not just use a non-relational database on-prem or in the cloud? Right, so I think I touched upon that earlier. If you want to use a non-relational database, that's totally up to you. However, sort of non-relational databases come with the complexity that we talked about, right? If you need relational semantics, and most mission-critical data does, right? Like bank systems, telco systems, healthcare systems, right? When you need relational semantics and you're trying to use a non-relational database, what that means is you've given up on transactions of the system, you've given up on strong consistency, you've given up on structured data, you've given up on SQL. SQL-like is not the same as SQL, right? Anybody who's used a SQL-like system can know that it's not SQL. So you've given up on all of those to get the scale with these non-relational databases. And if that works for you, great. But it does mean that if you need those things, you have to build them in the application. And anybody who's even attempted to build them knows that this is super complicated code. It's got so many sort of edge cases that you have to sort of think about and take care of. It's brittle because actually rolling your own transactions in the application layer is hard. Coordinate in the sharded solution, for example, right? Doing the logic to join between two shards and all those kinds of things are really hard. And again, if you like doing that kind of stuff, that's great. But for most people, they're trying to just build their applications to run their businesses, right? And they don't want to worry about these things. In that case, non-relational databases just don't cut it, right, for what they need. Okay, what's the difference between Cloud Spanner and BigQuery? Can't I just use BigQuery? So it's basically the difference between OLTP systems and OLAP systems, right? So are you looking for an enterprise data warehouse, or are you looking for a operational mission-critical database, right? That is literally when you would choose one or the other. Cloud Spanner for OLTP systems and BigQuery for OLAP systems, or enterprise data warehouse. So if I were to think about it in the on-prem world or in the sort of traditional world, it would be the difference between Oracle or SQL Server and Netezza or Teradata, right? That's the real difference. And in fact, we're basically trying to make it simple for customers to use their operational data in a data warehouse with Cloud Spanner, BigQuery. So you don't have to have complicated tools for ETLing data out of your relational database, out of your operational database, and moving into your data warehouse, right? Like there are simple tools that we're working on that will just basically allow you to quickly transfer data from Cloud Spanner into BigQuery, and then over time that you don't even have to do the ETL at all. It can be as simple as a push button thing. Moving on, does Cloud Spanner have every feature that traditional databases do? No, right? It's a different take on the system. So there are specific features that Cloud Spanner doesn't have now that we're working on to fill those gaps, like DML obviously, and backups and sort of things like that, and triggers and queues. These are all part of our roadmap, right? So I would hope that our audience and our customers give us some time, because we just launched last year, and traditional databases have been around for 30, 40 years. So we're trying and moving very fast, and we're going to close those those relational database feature gaps that are critical, right? There are certain things that are not critical for relational databases that are somehow are supposed to be. stored procedures, for example, right? That's just a way of pushing down application logic into sort of the database layer, which we don't actually think that's the way we want to go, right? With our system, we want to have a lean, mean database that can sort of do the things you need it to do, which is strong consistency, application, transactions, et cetera. And we want to give this to you in global scale, right? But we think that application developers know best how to write their applications, and that's the way we kind of want to offer this service. So with Cloud Spanner, with a new take on databases, we were able to sort of go back to first principles and think about why databases exist and what they're needed for, what they're used for, right? And we were able to sort of cut out all the flack cruft that's been building up in databases for a while, and we were able to go back to first principles for databases and then provide the features and functionality that are truly core for databases, especially relational databases. And as I said, yes, it doesn't have every feature right now which we're going to fill, but it also has features that no other relational database, or in fact no other database has, right? Which is global, strong consistency, replication out of the box, and transparent, securities, again, built in and transparent, et cetera. Next question. Why is sharding a database so difficult? It's if you've ever sort of had to shard a database, this would be sort of an obvious question, or obvious answer, really. So think about a database with a bunch of tables, right? And now think about the fact that you can't actually buy a big enough box to hold all that data in all those tables. So what you have to do then is, and I'm going to simplify here, there are many things that go into consideration here, but at the simplest level, what you have to do is basically take the table. If you have 10 tables, take each table and then put it on a different database, right? Because that way, at least the data set for that table is going to fit in your traditional, single box machine. So you have 10 tables across 10 different databases. So it's, of course, you can just keep using your tooling, and you can keep using transactions, all for within that table, or maybe two tables, right? With a table and an index, let's say, right? But it behaves exactly the same as one database for that one table and its one index, right? But if you ever had to do anything across those tables, then you have to write the transaction logic in the application to do the joins and to do the transactions on them, right? So you essentially will have to write the protocol to commit a transaction that is done in a database inside the application layer without having the sort of engine that runs the system, right? The database engine is what runs these transactions, et cetera, and does the consistency and guarantees, et cetera. So to do that in the application layer is extremely hard, and as I said, very brittle, right? Because what happens when if you're doing a two-phase commit, for example, what happens if one shard is unavailable but the other shard committed? So do you roll back that shard, or do you retry on the first shard, right? And what happens if during the commit there was a network outage, right? So do you know whether the transaction committed or not, right? Like, how do you recover from that state, et cetera, right? So there's many things that go into making a sharded database work well, and all of them basically make the application developer's life very hard. So those are some of the questions we had. I don't think we have any more questions, so I think we'll call it a day. And thank you again for watching and for tuning into our live webinar. As I said, we have these live webinars for Cloud OnAir every Tuesday, so please log in next Tuesday for our upcoming webinars on collaboration and productivity tools, as well as machine learning, among other topics. Thank you so much. Have a great day.